You don't want a ton
You measure your excitement in tons of TNT.
Bruh.
And you know you have something really awe-inspiring when you start using megatons.
Nuke. Those are thermonuclear weapons, sir. You're insane. No, so there's a fistful of hair,
kilotons, you can get a nice little explosion. But once you're in the mega, maybe even gigaton regime.
Gigaton? Sir! Gigatons. That's like annihilating the planet.
Oh, not quite.
What do you mean not quite? We've never...
It'll be fine.
I don't think... I guess no. I think what's the largest... The Tsar Bomba was 100 megatons. Right?
Yeah, you're fine. You got
so 1
gigaton. Magnitude.
1 gigaton.
Magnitude.
It's a whole order of magnitude bigger.
One order of magnitude. You're fine.
Yeah. Anyways, like I said though, no, and then I gotta buy that dog collar for July, and then August. That's probably like a $30 video. Like you're gonna buy sugar, corn syrup. I already have sugar, so we just need to buy corn syrup and like Coke, lots of Coke. Mentos.
Back to the envelope calculation from online says 60 zetatons.
68 zetatons? Is that what it takes?
60 zetatons.
Is that what it takes to wipe out the planet?
10 to the 24.
Is that what it takes to wipe out life on the planet?
That's what it takes to destroy the gravitational binding force of the Earth.
Oh, that seems excessive.
Basically, if we think of like an infinite number of like shells, each shell is gravitationally bounded to the next. When you integrate from 0 to the radius of the Earth, you can find out the amount of gravitational binding energy that there is.
Yeah, I know what the
60 zetatons.
Does that exceed? But does that exceed the chemical bonds?
Overkill. It is a bit of overkill, but it would get the job done.
Does that exceed the chemical binding?
The gravitational binding energy. We don't care about chemical binding. Is like atoms. Is like the inner parts of the nucleus binding together. Right?
Maybe gravitational
binding.
Actually, you know what? On an explosion you know what's crazy about an explosion that big?
The EM force is 1,000 times stronger.
Yeah, but you know what's crazy about an explosion that big?
What?
Is that it's probably so big that it will self-feed itself.
Self-feed?
Mm-hmm. So when it starts, right, it's going to rip atoms apart, which will generate more energy, and which will then be able to tear more atoms apart, which will tear more, and it'll be a chain reaction. You actually don't probably need
until the whole Earth is gone.
You probably don't even need an explosion that big to completely rip the planet apart.
It's a bit of overkill, but it would get the job done.
What?
That's what I said. It's a bit of overkill, but it would get the job done.
It might rip a hole in the. And that won't. I was making it. I was going.
It will not rip a hole in space time.
Yeah, I was about to say. I'm like, we need. That's an interesting question. How many zetatons? How many zetatons is a supernova?
It's just a void in the solar system.
What?
I said there would just be a void where the Earth once was in the solar system.
Yeah.
Everything that ever was is vaporized. Gone. Matter to energy. Gone.
It might. My question is, how many zetatons is a supernova?
It's not even. I don't even know if it's same scale.
Well, I mean,
Uh,
is it
I don't know.
terazetatons?
I don't know if there's a number put on that.
Well, we can look up the number of joules in
No, like I'm saying, I don't know if a number has been put on that.
We're gonna look it up.
10 to the 44?
10 to the 44 joules. So,
Wait, that's for
I want to convert.
supernova.
What?
Yeah, supernova. Yeah.
I want to convert joules to.
Well, no, it'd just be 24. It'd be 20 of those.
1 petajoule.
20 magnitudes of those.
10 to the 10 to the 44. 1 to the 1 petajoule. So here. See if you can make sense of this.
What am I looking at?
Hold on, it's going live. This. What does this tell us? So this is the number of joules. 10 to the 44 is the number of joules in
No, you need to make the number bigger.
What?
The number is too big.
Yeah, I know. So
You need to change your unit on the right.
I can't go any further. I can't go any bigger than petajoules.
Oh, why?
What do you mean, why? I don't think humanity produces 1 petajoules in a year.
But what is petajoule?
Peta comes after tera.
1,000,000 billion.
Yeah. Amount of energy humanity produced by humans in a year. This is the U.S. I want the world consumption of energy. World consumption. Oh my god. Oil. That'll work. Energy.
Well, why does it do that?
What is what?
It's wrong. Change your caret key to an E.
Hold on. What are we? Hold on. Here?
Yeah, your conversion's wrong. Change the caret key to an E.
Ah.
Why is it doing that?
I don't know. I put the caret in there.
What?
I put the caret in
you
there.
put the caret. The caret's wrong. Because otherwise it's saying that your number of joules is smaller than a petajoule. That number of joules should be bigger than a petajoule.
Hey, but look at this. It's only 9.9 petajoules.
No, but that's what I'm saying. Why is Google doing that?
Hey, that ain't half bad.
Why is it interpreting a caret key?
1 supernova is less than a zettajoule.
Why is it doing that?
Hey,
I'm intrigued now.
Well, regardless, one supernova. This can't be right.
1e to the 2. See, why is it doing that?
But this can't be right. 10 to the 44 joules. That can't be right.
What?
You're telling me this number and this number are the same.
So peta is 10 to the 15.
So this is wrong.
I don't know what your conversion's doing.
Yeah, this is wrong. Because this is not this.
How is it calculating that then? How is that calculating that?
Don't know. It's dividing.
I'm telling you, your conversion.
Divide the energy value by 1e plus 15.
Put a plus in there.
Oh. Same thing.
Do not change it.
Well, let's try this now. There we go. No, it's still negative.
I cannot see the number.
It's still negative.
No, it should not be smaller.
How the fuck is it? Why is it going negative? Well, this is useless. Well,
that's what I don't get. What the caret key is doing.
Let's bring up a calculator here. You can't see the calculator, but that's all right. Currency, volume, length, energy, perfect. Joules, British thermal units, kilowatt hours. Fuck. It doesn't go big enough. Fuck. Well, there's a way to solve this. Wolfram alpha.
I think it's 1 to the 29.
Wolfram alpha.
I think it's 1 to the 29.
I don't know. Either way, we need to zeta. How many zeros is a zeta?
What?
How many zeros
Zeta
is zeta?
is 21.
21.
Yada is bigger than that. It's 10 to the 24.
Yeah, but we want to know how many Earths can a supernova destroy.
Oh.
Although that conversion doesn't even make sense, because that's in zetatons of TNT, not zetajoules.
Yeah, you need to convert to joules.
Fuck. How many tons of TNT? Tons of TNT. The amount of joules in 1 ton of TNT. Amount of energy in 1 ton of TNT. Holy fuck. 4.18 gigajoules. Yeah, that sounds about right. Fuck. Well, that doesn't make it better. 10 to the 44 divided by 4 to the... What is that? 9? Right?
Yeah, he's going to divide it out and figure out the number. Pull out your calculator again.
But no. A gigajoule.
Giga is, 10 to the 9.
Bruh. No. No. 4 times 10 to the... No. It's dumb. This is dumb. No. It doesn't make a dent.
Well, why is it 4.184? Do you know that number is the specific gravity of water? Or, no, not this, the specific heat capacity of water. 4.184. Is there any reason why the number is a coincidence? Is it a coincidence, or is there a reason for that 4.184?
I don't
That
know.
4.184 is the specific heat capacity of water. I don't know if there's a coincidence, if that's just a coincidence, or if they're actually related, if that's how it's calculated.
It's 1 gigacalorie. It's a lowercase calorie. It's got to be
Yeah, then that's why. That's why. 1 calorie equals 4.184 joule, right?
Yeah.
Which is the specific heat capacity of water.
It's got to be a coincidence that 1 ton of TNT is exactly
Yeah. Why is it that 4.184?
1 gigacalorie. That has to be a coincidence. That has to be a coincidence.
Because that is a specific heat, that number, 4.184. I know that number. I know that number anywhere.
Yeah. What? That has to be a coincidence. Yeah, 4.18. Look, it's the same. It persists. See? So if we upgrade it to mega, it's still 4.18.
Well, you're just changing the units at that point. But where did that 4.184 come to begin with?
That has to be a coincidence. Right?
I don't know. I'm asking how they calculated tons of TNT.
What?
Did they use specific heat of water in the calculation? I don't know how they calculate the amount of joules or whatever. I'm just saying, did they use specific heat of water in the calculation? Because I could explain it. Or is it just that big of a coincidence? Like literally all 4 numbers are the exact same. In that order.
Well, let's Google how to find the amount of energy produced in an explosion. Equations for determining the explosions. Holy shnikes. Here's the explosion, the ambient pressure, the burst pressure of the vessel, the volume of expanding gas in the vessel, the capacity, the ratio of the gas, unitless. There you go.
You found it?
Are you looking
Is that
at
a
it?
reason? No.
No, there's no. It's a coincidence.
Oh.
Because look at this look at this. Look at this. It's a coincidence. If they're using Broad's method, of course.
What is this site you're on? What is that? What does that say? Equations for determining what?
Onlinelibrary.wiley.com.
Oh, energy of explosion.
Equations for determining the
Nice.
energy of of explosion.
See it.
I don't know what this website is. This is just a PDF.
I found it. I'm
Abstract.
intrigued.
Study.com. It's the same equation. Yeah, Broad's method.
Well, no. Gamma is in the equation. It says the heat capacity ratio for the gas. Are they using water vapor as the gas?
That's an interesting question. I don't know. Maybe they are. I don't know. I don't know. They might. They must. right? I don't know why they would be, but they must. Maybe that's the easiest way, is like the submerging explosives in water. Maybe that's the easiest way to find to figure it out. I don't know. I do know that's how we find calories, is with water. You know, because 1 calorie is how many joules it takes to raise water by 1 degree centigrade.
Yep. No, but the answer that it should have been earlier, back to earlier, it should just be 10 to the 44 divided by 10 to the 15. That is how you calculate that.
Right.
And I don't know what your converter was doing.
I don't know. It's Google. Don't ask me. Google's broken. Google, fix your crap.
That number comes out to be 1 to the 29.
1 to the 29 petajoules.
Yes. 1 to the 29 petajoules.
We still have to convert that to zettajoules.
Oh, you can do that.
I don't want to do that. And then convert that. Well, actually, no. That's we actually have to first convert our joules into tons of TNT.
Oh no, we'll just go straight to. Just skip the whole petajoules. Let's go straight to zettajoules.
No, remember, it's zettatons of TNT. Remember, it was zettatons of TNT, not zettajoules.
Oh.
So we have to convert our joules into tons of TNT, which we can then convert into zettajoules, zettatons of TNT. Which is just like whatever, like 2 steps after a yada, pretty much. Because like I have more zeros. If that makes sense in my mind. That's not actually how that works, but I'm just going to picture that is how it works, even though I know it's wrong. Anyways.
Big number.
Big number. Still stupidly big. In the, probably in the vegetillion range. I think vegetillion is...
What?
What?
The what? No, the what range?
Vegetillion.
Vegetillion?
It's like 1 to the 6. It's like 10 to the 60th.
Oh! I'm sorry. I know what you're saying now.
Yeah. Because you go trillion, quadrillion, quintillion.
No, it's quadrillion.
Yeah, sorry, I know. I don't know what the fuck I was saying. Quadrillion.
Quadrillion.
Quadrillion. Quadrillion. Quintillion. Sextillion. Septillion. Octillion. Nonillion. Decillion. And then it's uns decillion. I don't know how to say it. I don't know how to say that one. And then it's dodecillion. Tridecillion, quindecillion, quadricillion, quindecillion, sextecillion, septicillion, and then you have octocillion, nondecillion.
Actually, it's novemdecillion.
Right, sorry. It's been a while since I've been up that high in egg. Yeah, since I've looked at the numbers that big in egg ink. And then, vegetillion.
Vigintillion.
The vegan number. Just like 10 to the 60th, right?
10 to the 50, 10 to the 63.
Oh, so it's too big.
That's in short number notation. Large number notation is 10 to the 121.
Yeah, but everybody uses short number. But everybody uses short number.
No. But no, I'm telling you, if you use the large number way, it makes everything make so much more sense.
Yeah, I
right?
know it does. We've gone over this.
Numbers count much more simply.
63. So vegetarian is 63. So we only need 40. Oh, so we can stop at like undecillion.
Mm-hmm.
Right? That makes right because that would be like 10 to the 30.
You should have enough room.
Oh, so we don't want to stop there. We want to stop at quindecillion. Quadecillion, somewhere in there. That'll get us roughly in the right place of where we need to be. Joules. Oh my god. But like, cause what? So giga is billions, right?
Mm-hmm.
Yep. Giga is billions. What's after giga? Tera, duh. Tera, which is trillions. That's nice and easy to remember. Tera is trillions. And then after Tera is peta. Peta doesn't line up with quadrillion nicely. It lines better up with peta. I think when I hear peta, I think of a pentagon. I think of 5, which doesn't line up with quin.
Yeah, I don't know why they've chosen a number there.
We'll never know. Anyway, so peta is
it
quad.
Should be something as a 4, right? It should be something that kind of goes along the lines of a 4. I would think.
What comes after? So, because like obviously there's zeta and yocta, but what the fuck comes after peta?
Exa.
Hecta?
Exa.
Exta.
Exa.
Which is quintillions. What's after?
So like exabyte.
Okay, exa. What's after exa?
Zeta.
Zeta is sextillion, and then yocta. Yada. Sorry. Yada is septillion.
And then there's the last 2, which I don't like. I think they're awful names. For me personally, 10 to the 27 should have been named Hella.
Yes.
So what did they choose? They chose Rana.
Rada?
Rana and then Quetta.
Rada and what?
Quetta.
Quetta. Okay, so Rhonda.
Oh,
I'm
actually,
gonna call it Rhonda.
No, the sun is in Quetta.
What?
One Quetta. No, it's kilograms. Yeah, one Quetta kilogram.
Okay.
1,000 quettagrams. Right?
Yeah.
I think so.
So
1.9 times 10 to the 30.
So a Rhonda. We're gonna call it Rhonda. Rhonda's easier to remember.
What?
We're gonna call it a Rhonda, the previous one.
There's no D.
I know, but Rhonda. Rhonda?
Rona?
Rona?
I don't know. Ronna.
Rana. Well, if it's Rana, it reminds me of Rhonda.
Vowel? Is that a short or a long vowel? I don't know.
Well, if it's Rana, it reminds me of Rhonda. So I'm just going to say Rhonda. So Rhonda, Rana is octodecillion. Octillion. I know. There's too many big numbers, all right? Octillion. And then the last one, whatever. What was it? Quetta. The Quetzal, we're going to call it. Reminds me of the dinosaur, the Quetzal. Is non-decillion.
Nonillion.
Fuck! I keep jumping to the next.
Decillion.
Nonillion.
Yep.
And then we don't need anything bigger yet, right?
Yeah, not really, no.
Will we need anything bigger?
I mean, if you want to talk about the massive, like, Beetlejuice or something.
Oh. Well, no, because, like, we haven't exceeded anything. So we're in the... Oh, we're in the exabyte.
The mass of the sun is basically
how many
2
bytes of energy? How many bytes?
kilograms.
How many
Or
bytes?
2,000 quetagrams.
How many bytes are there?
1,024?
No, I know. No, I'm just wondering how many bytes are in the world. How many bytes of storage the world has.
Oh, I don't know.
See if my printer's working or if it's still broken. I'm gonna have to manually clean it.
What are you printing?
Printing a blue square.
A what?
A blue square. My blue square came out black.
Why?
I don't know.
Well, why are you printing blue square?
Because I'm trying to print this thing for my, well, this is what I was getting before. So now we have no color at all.
You need to put new color in it.
No, it has color. The ducts are clogged. See, there's a square on there.
I thought you bought this printer so that issue would never happen.
Yeah, well, it needs to be cleaned manually.
You told me you bought this printer because you didn't want that issue to ever happen, because you said you're going to rarely print, but when you do, you want it to work.
Well, you have to... Well, yeah. I don't know. Long story short, well, the black works. It's the color that's clogged for some reason. Which is weird.
Mm.
Why would the color clog but not the black? That doesn't make any sense. Doesn't matter.
Look at the draw.
I guess. I don't know. Probably. It's a 1 in 4 chance.
That's the way the cookie crumbles.
Something like that. Yeah. Well, anyways. We are over time. We always go over time when we're doing the Zoom. That was a good podcast, though. We had a lot of interesting discussion.
What did we even talk about? Conversions.
No.
Conversions and guns.
Nope. We just, nope. This is all you need in life. 3
Math
aspects of
coding
life.
in China.
Yep. Anyways.
No. That should be, say, math coding in China.
No, it's meth.
No. We don't need more than one type of drug.
Yes, you do.
One drug, one universal language.
Fine. It's math, and code. It's math, and China.
No. There needs to be 3. Oh. No, that's too many M's.
That's the point.
Math cocaine in China? Math heroin in China?
Math drugs in China?
Drugs in China?
Yeah, anyways, I would like to thank you all for watching. Please like, comment, share, and subscribe. New podcast every Friday, noon, Central Time. And good night.